everyone. So today we're going to be moving into our factoring unit, and we're going to start with something called GCF factoring. We're going to take a look at some level 1 questions and then questions that deal with just variables. But yeah, let's get started. So first, let's define some keywords that we're going to be using a lot. First one should be familiar: factors, numbers that we can multiply together to get another number. So for example, the factors of 6 are 1, 2, 3, and 6. 2 and 3 are factors of 6 because 2 times 3 equals 6. So you might have remembered in elementary school, like you can make that rainbow. So 1 times 6 gives you 6, 2 times 3 gives you 6. And this is not the same thing as a multiple. A multiple, you'd be multiplying like 6, 12, 18, 24. But these are the numbers that can go into 6 that when we multiply them together, they give us 6. Okay, so what we're going to be doing is factoring. So we're going to be finding what multiplies together to get an expression. So basically what that means, we're going to be doing the opposite of distributing, or the box method, where if something was on the outside of parentheses, we would multiply to the inside to combine them. We're going to be doing the opposite and separating them. Okay, we're going to be using the GCF, greatest common factor. Hopefully this sounds familiar also. It is the largest number or term that divides evenly into 2 or more numbers or terms. The reason why I'm saying term is because we are going to be looking at expressions with only variables, not with numbers. So I want you to know that the GCF refers to the numbers that we're talking about and to the variables. If we were just talking about numbers, if someone were to ask us, find the GCF of 8 and 12, you list the factors of 8 and you list the factors of 12, and you see the largest one they have in common, which is highlighted here, is 4. So that's the largest number that can be divided into 8 and 12 evenly. Okay, so let's get started. So here we're going to be looking at the numbers only. So factoring out a GCF, we want to factor the following polynomial completely. So basically, we want to undistribute. That's a way to look at it if you want to. This has an x, this has a 10, so we know that we can't combine these or anything. So don't make this 25x. And remember, we're going to be breaking this into 2. So the first step is to find the GCF of the coefficients. Coefficients meaning the numbers in front of the variables. So this doesn't have a variable, but I'm going to just still consider that a coefficient. It's really a constant. But we're going to be finding the GCF of these two numbers here, 15 and 10. So you have to list the multiples of 15. I'm sorry, not the multiples, my mistake. The factors of 15 and 10 and see the largest one they have in common. You might be able to do this in your head. If not, it's okay. Write down your factors and see which one they have the largest one. So the factors of 15 are 1, 3, 5, and 15. Of 10, it's 1, 2, 5, and 10. The largest one they have in common is 5. Okay? So that's the first step. Second step is we're going to divide each term in our expression by that GCF. So I'm going to just rewrite the GCF here. The expression here. We have 15x plus 10. And what I'm going to do, and I'm actually going to write this over here. So our GCF is 5. That's important to note. So I'm going to divide both of these terms by that GCF of 5. Okay? So when we do that, I'm going to write our answer in parentheses and put the GCF on the outside of our parentheses. Please do not forget to put the GCF on the outside. That's like the number one mistake, at least in my experience. Okay, so I'm going to have a set of parentheses here. I'm going to put the 5 on the outside. And then I'm going to divide now and put those answers inside the parentheses. So 15 divided by 5, this we can simplify here. 15 divided by 5 gives us 3. And I'm going to just bring the x down. Plus 10 divided, and maybe I'll just even draw arrows so you know where those numbers are coming from. And then 10 divided by 5 is 2. So we just brought down the x and we divided the numbers. 15 divided by 5 is 3. 10 divided by 5 is 2. Put your GCF on the outside, and that is your answer. a really quick way to check your answer is to just distribute and see if you end up with what you had in the first place. So if we were to distribute, which you don't have to do, this is your answer, but to check your work, if we distribute this 5x, 5x, 5, I'm sorry, if we distribute this 5 times 3x gives us 15x, which is what we started with up here. And then 5 times 2 gives us 10, 15x plus 10. So if we were to distribute this, we would get the same thing. We know that we have the right answer. Okay, so let's take a look at an example where we only have variables. Okay, so factor the following polynomial completely. X to the fifth, y to the third, plus x squared, y to the seventh. So it's a little different here. So the first thing that we're going to do is we're going to identify the term with the smallest exponent for each variable. So both terms, we're going to put both of those terms together. That's going to be our overall GCF. So you're going to see what I'm talking about. But we only factor out a variable if both terms in that expression have that variable. So for example, if there was no y to the seventh here, y would not be part of our GCF because it has to be in both terms. It is in this case, so I'm going to make sure that we do focus on it, but we'll take a look at it in another example. Okay, so I'm going to explain to you what I mean about this first step. So I'm going to find the GCF of the x variable. So I'm going to identify which x has the smallest exponent. So this one has a 5, this one has a 2, this one's the smallest one. That is the GCF of our x, because that is the amount of x's that they both have in common. All right, I'm going to do the same thing for y, the GCF of y. So I'm going to look at my two y terms. I have y to the third and y to the seventh. I'm going to identify which one has the smaller exponent, which is y to the third. So that means our overall GCF of this whole expression, I'm going to put both of these together, is x squared y to the third. Like I said, we only take out a variable if it is in both terms. So if we had another, like say we had another expression here that was just x to the fourth, we wouldn't even look at y because y has to be in every single term. Same goes for x. Okay, so now that we identified the terms with the smaller exponent for each variable, the next step is to divide each term by the GCF. And just a hint, we subtract exponents of like bases. So we're going to do the same thing where we take our expression and we divide by the GCF. And I'm going to set my answer up and just put it, so the third step is write your answer with the GCF on the outside of the parentheses. So I'm going to just go ahead and do that right now and fill in our parentheses as we divide. Okay, so now I'm going to divide both of these terms. Oops, that should be a 7. I'm sorry about that. That's why it's always good to check to make sure that you are writing. We have a 5 and a 3, a 2 and a 7. Perfect. Okay, so now I'm going to divide by this GCF. Okay, so I'm going to focus on the y's here. I'm sorry, on the x's first. So I have x to the fifth divided by x squared. We're going to subtract these exponents. 5 minus 2 gives us 3. That becomes our new exponent for x. So this will be x to the third in the first term. Now here we want to do the same thing. We're going to focus on the y's. If I can find this. Okay. So we're going to subtract these exponents, y to the third over y to the third. That would give us 0. So these technically cancel out because anything to the 0 power is 1, so we don't need to write that 1. So if you have something divided by itself exactly, if they have the same exponent, you can just cancel those out. All right, then we have our plus sign that I'm going to bring down. So x squared divided by x squared, same thing. They have the same exact variable. So those can just, the same exact exponent. So those are going to just cancel out. And then y to the seventh divided by y to the third. We're going to take these exponents and subtract them. That gives us y to the fourth. And then that is our answer. Remember, you can always distribute to check, which we can do real quick. X squared times x to the third would give us x to the fifth. And then we don't have a y to multiply, so we would just bring it up, y to the third. And then x squared, y to the third times y to the fourth. We would add our exponents just for the y, which would give us our second term. Good. All right, let's take a look at two more examples just so you can get the hang of this. Okay, the first one, factor, we have 12 plus 8y. So this does not have a y, so we are only going to be focusing on our numbers here. Now this, we talked about the GCF of 8 and 12 in that definition slide. The GCF of 8 and 12, the largest number that can go into both of them evenly is 4. So what I'm going to do is divide both of these by 4, put my 4 on the outside of my parentheses, and then divide. 12 divided by 4 is 3, plus 8 divided by 4 is 2, and bring down the y. That's it. So when you have numbers like that, it's pretty simple. Just think of the GCF of those numbers, divide. Don't forget to put the GCF on the outside of your answer. Okay, example number 2, we have a times b to the sixth minus a to the fourth. So we can see in this example that they both have an a, but only one of them has a b. So the b will not be part of the GCF because it is not in both terms. So our GCF here, we have it a. Remember, if it doesn't have an exponent, it has an exponent of 1. So a to the first power and then a to the fourth power. I know that these are different fonts, so if it's throwing you off, I'm sorry. It threw me off a little bit. Identify the one with the smallest exponent, which would be this one, a to the first, which is just a. We don't really need to write to the first power. So now what I'm going to do is I'm actually going to just take this expression. You can rewrite it if you want and divide both of them by a. I'm going to just put this in its own little box over here. So a on the outside, and then whatever I get as an answer, I'm going to put inside the parentheses. Now a over a would just cancel out. They both have that exponent of 1. And you would just bring down that b to the sixth. You wouldn't touch it because we're not dividing by a b. Minus a to the fourth over a to the first. Subtract your exponents. 4 minus 1 gives us 3, so we get a to the third. Make sure you put your answer, you can box it so you know that's your final answer. Distribute either on your paper or in your head if you want to check your work. But yeah, that's it. So just make sure you identify your GCF from your numbers, and if you have variables, you take out the variable that has the smaller exponent.